is the elite naval branch of the Indian Armed Forces, capable of operating above, on, and below the surface of the great oceans. The Indian Navy is considered to be one of the best navies globally, has a lot of successful operations under its belt, which helped India in many critical conditions. The courage and patriotism of Indian sailors, along with the cutting edge equipment and ships provided to them, helped the Indian Navy to become such a recognized naval force. The variety of naval ships India has helps it to neutralize and engage any modern naval threat that the country may face. We are honored to have the shipbuilding department with us, which is one of the vital backbones of any modern navy. So I welcome Mr. Gaurav Tehlan and Mr. Gulam K. Asad, who will join us shortly. Welcome, sir. The stage is all yours.
Okay, thank you, Hari Krishnan, for your introduction. And I hope I would do justice to my duties by just sparing some amount of time. I would be covering some of the portions which will be very basic, so that the audience which is watching it, they may be able to relate it. So I'll start sharing my screen first. Is it visible?
Yes, it's visible.
Okay. Okay, then first of all, I would like to give you the introduction of our department. The Department of Ship Technology. Basically, the students undergo the BTech in Naval Architecture and Shipbuilding. So, in this particular presentation, I will be covering the what kind of models which have been made, and why do we make this kind of models, and what is the use of it, and some industrial aspects which are related to the shipbuilding industry. I will be covering in this presentation. I am 8th semester student, and I'm going to complete my course now. And Kalim Azad, he could not come because he had some engagements in department, so he'll be joining us soon if possible. So maritime industry, what does it cover? Is there are various kinds of ship. For for a layman who is not aware of the various kinds of vessels and all, I will be covering these all types of ships which we have and the operations of these ships according to their features. So it is the most everything which connect the sea or the waterways throughout the world, because you must have seen the massive ships. Whenever you hear about a ship, a single word comes to your mind. That is, it is something which is very big. And that's not the case. First of all, there may be the ships which are very small. There may be the ships which are very big. Basically, it is only based on the functionality of the ship. What is the use of that ship and why it is being used? And for a matter of fact, I have given a third point, that is 90% of the world trade. It is being carried out by the international shipping industry. When we talk about small transportation, that is railways or buses, public transport, whatever it is, it, when we are talking the internal movement of the transportation, that may be done by the trains, may be done by the public transport. But when we are talking about the international relations, the fuel which you are using for your vehicles is being imported from some other country by the means of shipping itself. Now, ship production. The picture which you can see, this picture, there is a crane on top of a ship. This is not complete ship. This is a docked ship which is not been immersed in water, and they are basically, it is in a building phase. They are making it. So we call it the ship production. How it is being produced. So they are other than this, we have floating docks also. We can call it floating vessels. Those are known as the floating vessels. A dock is a place where we keep the ships for the maintenance for some time. Per se, a ship is operating in water from past 5 years, so there may be some corrosion, there may be some fouling, or there may be some damage to the hull, which needs to be corrected after some period of time. So that time, what will happen is we'll take a ship, we'll lift it up, or otherwise we'll take it in a dry dock. Then we will remove the water, and that particular underwater hull, underwater surface of the ship is being repaired. The red part which you can see in this figure is the underwater hull of the ship. Now there is advancement in the each and every sector of the shipping industry. When we talk about any, if you take any sector, if you take about the technology, it is advancing day by day. So same thing is happening in shipbuilding as well. Ship or dockyard are the places where the ships are built or repaired. This thing I have already told you. I have already introduced you about this. So in modern world, what is happening is There are lots of advancements. Earlier, what they used to do is there were some manual mechanisms to take the ships to the dry dock or something like that. But now there are lots of technology which have come to make the shipping more easier. And one of the best technology which we have got in the shipping is the green shipping technology. That is, now the ships are running totally on the renewable sources of energy. We need not to put the diesel, we need not to put other fossil fuels to run our ship. We can directly put the solar panels on top of the ship and the ships can operate by using the non-conventional resources of energy. Now, as I said that I will be covering the type of ship for the laymen who are watching this. So, first kind of ship is that is container ship. As the name suggests, the container ship is something which takes the container from one place to another place. Now, these containers in photographs you can see there are some blocks which are kept on that ship. These are the containers of the ship. Now, these containers can contain anything depend on the functionality of the ship. This container can contain any kind of cargo can be contained in these containers, but basically there will be n number of containers which are to be carried on the ship. Now these ships are designed according to the capacity of the containers. Like if we need to design a ship for carrying the 100 containers, then we will multiply the length of one container to the 100, and accordingly the length and the breadth, basically all dimensions of the ship will be evaluated for the designing of the vessel. Second is bulk carrier ships. Bulk carrier ships are the ships which carry lots of bulk, lots of cargo, and you'll find these are known as the monster ships. These are very big ships. There's something known as CB, that is block coefficient. It is around 0.8 to 0.9 for this kind of ships, and they are hatching and folding arrangement which you can see, and there are some vertical pole kind of structure which you can see on the ship. That is nothing other than a crane. It is a crane, and this crane will be lifting the material from the jetty and putting inside the ship. Now there are some models which are being made in our department, and there are various purpose of making these models that I'll be covering in upcoming slides. This is the tanker ship. This tanker ship, as the name suggests, it has got the tanker. So basically it is used to carry the liquids. It can liquid, other than that it can carry gases, LNG carrier, let's say petrol, diesel, crude oil, whatever, from one country to another country. So tanker ships are used for that. This is the model which is made by the students. LNG carrier, liquefied nitrogen gas carrier, and these are the basically 4 tanks it has got. Now this is Roro ship. As you can see, there are some cars which are coming out of ship, and the cars are not only on the one deck. There are n number of decks in this ship, 4 or 5 decks. So this is roll on and roll off ships. These are used for the carriage of the vehicles from one place to another place. Conditional. The amount which is being invested in the ship, or being we call it the OPEX, operational expenditure. The operational expenditure of the ship should be less than the amount of petroleum which is required from the car to go from one place to another. I'll make it more simple. If a car is taking 100 rupees of fuel to go from one place to another place, when we are taking it through ship, it should be less than 100. Otherwise, there is no use of carrying these many of cars in a ship. I hope you understood the concept for this kind of ship. Then these are PAX ships. PAX means passenger ships. Now there are different kind of passenger ships, ferries and cruise ships. I am personally designing a passenger ship which is a catamaran. Catamaran is a twin hull ship, and it has got these solar panels on top of it and a wing sail on top of it. The sail tradition has been lost over the time over the period of time. So what I have done is I put the sail on it and solar panels on it. It is totally running on the natural resources of energy. There is no requirement of any fuel. Nothing is required. Yes, you need to put some batteries for standby, and those batteries need to satisfy some of the situations, some of the rules by statutory rules. And in case of any failure, or in case when I talk about a solar ferry, first thing which you will think is, sir, what if it rains? What if clouds are there? How will you operate your ferry? So I have answer for it. It can be operated in all type of condition because it has got battery backup. When your solar panel, when your wind energy, when there is no favorable wind, at that type of situation, the grid energy or grid power can be taken from the shore and batteries can be recharged and the ferry can operate. Yes, there is one demerit, or else you can say it's not a demerit at all. That is, it cannot operate above 7 or 8 knots. That is not possible. So this kind of ferries can be used for tourism purpose. That is possible. Then these are offshore vessels, help in oil exploration, construction jobs at sea. There are several types like supply ship, pipe layers. Supply ship is when there is big ship, you want to supply something to that big ship by using a small ship. So for that purpose, this ferry use pipe layers. You need to pipe laying vessel or cable laying vessels are there. You need to put pipes into the sea. Sometimes it is required. You need to lay the pipe. Then semi-submersible drill rigs. This is something which is half immersed in the water. This ship is half immersed in water. You won't be able to see the deck of the ship. Drill ships for using when we are extracting oil from the sea. That time this kind of ships are used. Production platforms, accommodation barges, and there's something which is related to it, that is dredging. Dredging is done only inland waterways. When we talk about sea, there is no need of dredging. But when we talk about the inland waterways, you can take the example of Ganga River or Brahmaputra River. If any ship is operating in that, there may be some parts where the depth of the water will be less. So what they will do is they'll take a ship dredger. That ship is known as dredger. The dredger they'll take out the mud from the seabed or the riverbed, and it will be taken off and the depth will be increased so that the vessel can operate at its favorable conditions. Now, this is fish trawler, which you can see. This is a model made by us. In fish trawler, what they at the aft part of the ship, that is at the behind part of the ship, there is something known as the fish catching net, which is being operated by the manual mechanisms, and it is generally small in nature. That is around 30 to 40 meters. So maybe maximum it can be 60 meters, not more than that. This is used for catching the ships, catching the fishes. Now coming to the naval vessels, there are various kinds of naval vessels. When we talk about the naval vessel, the first thing is safety. Safety is the biggest factor in the naval ships. The naval ships are not so beautiful because they are not meant to. The naval ships should be fast, should be strong enough. The plates which is being used should be more thicker, should be heavy. That is the prime purpose of a naval ship. But other than that, there are various kind of naval ships like destroyers, frigates, cruisers, aircraft carriers, oil tankers, survey vessels. So all these kind of vessels have got different functionalities. Like if I say destroyer, as the name suggests, destroyer, the main aim is to destroy the vessel which is approaching us. Then frigates are slender hull vessels which are very fast. Cruisers, same. The aircraft carrier, the photo which you can see is the photograph of aircraft carrier. It can contain the aircraft on top of the deck, on top of it, and it will carry the aircraft to it. So it is quite obvious that the speed will not be high, but it is very big in nature and it can carry lots of aircraft on it. Oil tankers, they'll carry oil. Survey vessels for the patrolling of the jetties. If somebody is there who is staying in the areas which have got some of the maritime borders, like Kochi, Goa, whatever, those states which comes on the maritime border, they must have seen the surveying vessels, navy vessels which are there around us to monitor what is happening. Now, this the model which you can see is this is first model, top left. That model is of aircraft carrier. The second is frigate, and third is submarine. Submarines also comes under the modeling, same shipping industry, but the overall concept is different in the submarine because it has to immerse totally. Now coming to the fact that why do we need to make these models? See, there are lots of factors. I'll try to make it simple because it's a bit of complicated scenario, but I'll try to make it. First of all, is 3D outlook of the ship which you are making. Per se, you are a designer and you have started designing a ship. Then you need to understand that what are you trying to design. So before that, you need to model it to get the overall concept of the ship which you are going to construct, the ship which you are going to design. And this goes for all the industries. If you are constructing a home or constructing a big building, you are supposed to make a model of it to get the better understanding of it. Second is stability of the ship. You may amaze it that a ship is going into water, it is made up of steel, and why it is not sinking? That is the biggest question for a layman who is not aware about the mechanism of the operation of the ships. So stability is the biggest factor. It has got the buoyancy tanks, it has got the ballast water inside it. This is, I'll make this thing clear that the ship has got some tanks inside it, and water is filled in those tanks. That is known as the ballast water of the ship. This ballast water keeps on coming out, coming in, depending on the stability and the amount of buoyancy which is required for the vessel. So we need to test the stability, how stable ship is. So what we can do is we can make a model of same ratio of length, same ratio of breadth, and that can same hull form, kind of shape it has got, and the stability test can be done, and it can be extrapolated. The results which you are getting can be extrapolated for that particular ship, and we can theoretically we can calculate it. Then resistance is, uh, how will I make it more simpler? Okay, whenever you are taking something inside water and it is moving inside water, so there are some waves which are acting on the ship. When these waves are acting on the ship, it is producing some amount of friction to the ship. Basically, it stops the ship. For that, you are providing some power to it, and the ship is moving ahead. So that is why this calculation has to be done. That what amount of power is required to propel our ship, to take our ship ahead. Now various simulations has to be done before that. So for this purpose also is model. And sea keeping is how the ship is going to act in the waves if there is high sea state, or the wave height, or at different wave heights, at uh, different conditions of the sea. The sea keeping has to be checked. Like if a wave height 30 meter is coming, how my ship is going to act? Will it be able to withstand it? So this the turning of the ship, it may happen that we are turning in the ship and it capsizes. So these all calculation has to be done. It has to be done to the sea keeping methods, and for that purpose we use the models. And finally, the aesthetics, we make model to keep it in our wardrobes so that it looks good. And okay, choosing the hull form, this is the very biggest factor in the shipping industry. There are lots of hull forms which are there in shipping. The hull form which you can see is this is transom. This aft is very flat, and there can be twin hulls. Twin hulls mean two hulls joined by a deck structure that is known as catamaran. Or else you can have hard chine hull. Then so this hull form depends on the type of vessel which you are making. If you are making a passenger ferry, the hull form will be small. If you are making a bulk carrier or something, the hull form will be big. CB, basically block coefficient of that ship. Sea keeping, as I have explained it. So this is the ship model, which has to a mechanism, and it is being tested in a towing tank. Towing tank is nothing; it is just kind of like a swimming pool, which you must have seen. There is a water channel, in that you put your model, and various waves are being generated by the wave generator, and there is a damper at the end, which takes up the energy of the wave, and these models are being tested. This resistance, the waves which are acting, I already explained. Uh, there are some other laboratories which are there in our department, that is fluid mechanics. Fluid mechanics is the branch of physics concerned with mechanics of fluids. So basically, when our ship is acting in water, we need to study fluid mechanics also. These are some of the machinery which are kept. So basically, what we do is we make the ship models. We put these models inside the basins which are there, and various tests has been done. Okay, now this is CFD, computational fluid dynamics in shipbuilding. Uh, we are using lots of softwares by making models. We not only we are making models physically, we are making models in softwares also. That is Maxup is one of the model making software. AutoCAD 3D is one of the model making software. And then Rhino is one of the software. HMT is one of the software. BMS is one of the software. So there are lots of software which are being. NSYS Fluent is one of the software which is being used. So we make the models of the ship, and we find out various characteristics. Like you can see this in this particular slide. I put a photo of one. This is a ship, and there are the waves which are being generated. So you can find the sea keeping resistance, all these conditions at various speeds. You can find it, and you can analyze the results. This is the same thing. The alpha which you can see is NPL series. And now there is material testing lab. In material testing lab, you may be thinking how it is concerned with shipbuilding. Material testing lab is concerned with shipbuilding is like the kind of material which you are using is being exposed to the seawater for a long period of time. Long period of time, as in I have made a ship which is made up of steel. You may have put some of the paint coatings and something, but there are some waves which are acting on the ship. When the waves are acting, there are lots of loads which are acting on the ship, and these loads may cause the damage to the ship. So for that, we need to ensure that the material which is being used is appropriate for our ship. So for that, the material testing lab is being set up in department. So uh, these are very common tests which are being used. Charpy test, ISO test, so very VNOS test. Basically, lots of tests has been done. Material testing. The photo which you can see, this is the front part of the ship, and they are welding small plates on. So I'll tell you the basic skeleton of the ship, how it is being made. It is made by making a basic structure of the ship, different divisions. We call it bulkheads. First of all, we lay a keel. You must have heard of keel laying ceremony happening for various ships. We lay a keel. On top of it, we start putting bulkheads. Then then we make the transfer framing or longitudinal framing, or maybe the combination of both, and put the plates on it. The photo which you can see, they are welding plates on that particular structure. This is how the ship production is done. So what kind of materials are being used? Multi-wood. Multi-wood is something which is used for the models. And then wax and paraffin is being used to make the hull smooth, so that it is going at a good speed in water. Fiberglass FRP. The ship which I have made, which I am designing, basically I have not made it. I am designing a ship that is solar catamaran and assisted by wind. So in that I use the FRP because it is very light in nature and it will not corrode, it will not catch rust in the water, and it needs not to be painted with anti-fouling paints over the period of time. But only demerit is once the life cycle of the ship is over, you cannot reuse it. If the life cycle of a ship is 25 years, after 25 years you won't be able to use it. But if it is the case of steel or something, it can be used again. So they are accordingly they are merits and demerits of it. Now workshop tools which are being used: lathe, sander, drilling machine, saws, clamps, planers. How these tools are being used is like various applications of these things. So I'll show you some of the models of the mechanical shop also. See, this is a gear. Gear is used in lifts, elevator, pump, power plant, Davids, boat lowering. Boat lowering mechanism is you have got a ship. So sometimes there may be some emergency situation on the ship. So what you do is you have got some small ships. You will sit in those boats, small boats, and that crane will lower the boats into sea, and you will escape. You will leave your ship, parent ship, and you will go from there. Engines. So gears are used everywhere. It is very basic. This is a coupler used in shafts, conveyor belts, pipe system, engine room mechanism, power transmission system, propeller system. Propeller is something which is a kind of big fan which is being fitted at the aft of the ship, at the back part of the ship, to make the ship move ahead, to provide the thrust to the ship. This is piston model made by us. This is primarily used in the engines of the ship. Connecting rod made up of steel, used in engine propulsion systems. Pipe joints, coupler. It is a flange coupler. Shafts, propulsion systems. It is a vice used to hold your work, whatever work you are doing. You just put your work on it, screw it up. So this is also made by us. Refit and repair activities on board ship. For this thing, it is used. It is made up of steel, but basically it is of iron. generally. It is for a modern aesthetic purpose. That is why it is made up of steel. Now there are various classification societies, that is DNVGL, ABS, Class and K. I'll tell you the basic role of this classification society. That is, uh, whenever you got a ship, you need to adhere to some of the rules of the ship. Like there are some rules for this ship. Otherwise, nobody will adhere to some of the regulations. I'll tell you some of the regulations. Like you have got toilets on the ship, then you cannot discharge your waste directly into the sea. It needs to be treated, then only it can be discharged. If there is some garbage on ship, you cannot throw it inside it. Then when you are constructing a ship, at that time, what kind of steel to be used, what kind of welding procedure, everything, damn everything, for the reduction to the operation of the ship, to the life cycle of the ship. Whatever is the whatever elements we have got in the life cycle of a ship are to be adhere to the classification society rules. So for this purpose, we have various classification society rules, and for us, India, we have IRS, that is Indian Registrar of Shipping. Other than that, we have ABS, DNVGL, Lloyds, that is LR, Class NK. So lots of societies are there. Then there is something known as flag of registry, that should be of that particular country itself. So now I'll show you some of the 3D models. Just I'll switch the window. Okay, the ship which you can see is a general cargo ship. It is a general cargo ship. The model I have already shown you. In this, what these are the cranes. I hope you can see my cursor. These yellow things which you can see, these are the cranes, and these are the foldable hatches. These are the foldable hatches. See, we'll put our cargo inside this here in these sections, and this is the superstructure of the ship. And after that, it is folded and covered again. It is folded and covered. Okay, this part which you can see, this is the superstructure of the ship, and this is the propeller which I was talking about. This is the propeller. This is the propeller, and this is the rudder. Rudder is kind of tiller. It is used for giving direction to the ship. So this red part which you can see, and this white line which you can see, this white line, these are the draft markings. Basically, how much the ship is immersed into the water, and this red part will always be immersed into the water. Now you can see that why it is red and why it is black. I'll tell you the reason behind it. This red paint is different. We call it paint scheme for a ship. So this red color is different and this black color is different. This paint is different. This paint is I'll tell you the reason for the different kind of coatings which are being applied. That is because of, see, there are three conditions. One is the red part is totally in contact of water. That is condition one. This black part is in contact with air. That is condition number two. And the combination of both the layers, it is sometimes it is in contact of the air, sometimes it is in contact with the water. It is switching basically because of the waves which are acting on the ship. So the fluid is changing, the corrosion will change, the properties of the corrosion will change because some material is getting oxygen, some material is getting water, the property will change. For that purpose, we apply the different coatings of the paint. And now I will show you another ship, that is container ship. This is the container ship. In container ship, you can see various containers which are being kept, and this is the underwater hull. Same paint scheme is being used, and this is the propeller of this particular container ship, and this is the superstructure. Now there's a difference between the model which is seen previously and now, and this superstructure is here. In that ship, it was at aft. This thing which you can see, this is the exhaust of this ship. It means the engine is placed here, and okay, I'll tell you the mechanism of it. The engine is being placed here. I don't know whether you'll be able to enter this or not. Okay. No, that is not possible. Okay. Engine is placed here, and this propeller, this fan structure which you can see, is connected to the engine through that shaft, and it is rotating, and it is providing thrust to the vessel. Now these are the anchors, two anchors. It has got two anchors, and this is the bulbous bow of the ship. Now I'll tell you the uh, principle behind making this bulbous bow. Why did you place a bulbous? We could have made it plain hull over here. What happens is when the ship is moving ahead, there will be generation of the waves. In order to make, and those waves are going to act on our aft part, the total ship, on this total part of ship, the waves will be acting. In order to decrease the waves, in order to decrease the number of waves, the intensity of waves, we have made this kind of structure so that the waves are not acting on it. Because the more the number of waves, the more will be the resistance, and we need to put the more power to take our ship ahead, to propel our ship. Now I will show you the LNG gas carrier. The LNG, this is the LNG gas carrier. In this, these are the tanks. These are the tanks. This 1, 2, 3, 4, 5, which you can see, and this is the crane. LNG is liquefied nitrogen gas. This is superstructure accommodation area, the place where the people are staying. And this yellow thing which you can see, it is a lifeboat. If there is some problem with ship, people will sit in the lifeboat. This boat will be thrown into water, and people will escape from the ship. These are the anchors. This is the bulb also, same thing. It has got one crane here also. And basically these tanks are round in shape, spear in shape. 1, 2, 3, 4, 5. 5 tanks are there. So it is spherical in shape and connected with each other. Then this is a naval ship, quite interesting. This is a warship, and you can see this is the exhaust for the ship. This is the mast. In naval vessels, you will find mast in all the ship. This is the basic. This is very common thing in the naval vessels. Always you will find a mast in the naval vessels. These are the guns which are being fitted. Naval ships will not be much beautiful, but will be very strong and dependent on the functionality of it. As you can see, the red part is being immersed in water. You can see this. This is a stabilizer, roll stabilizer. If the ship is moving like this, if the ship is rolling in water, the stabilizer will make it more stable, because we have got ammunition inside the vessel, and those ammunition should be kept firm at its place. In order to ensure that the roll stabilizers are being given, and okay, these are the anchors of it. This is the quarter deck, and these are known as the fair leads, through which the mooring arrangement basically when we want to tie a ship, mooring arrangement will go through it. And this is the David arrangement. You can, well, try to zoom. Yes, this is a lifeboat which is being hung on this. Okay, this is also one of the lifeboat. You can see here. See, this is one of the lifeboat. People will sit in it, and it will be directly put into water, and people can escape from the ship. So, okay, this is last ship, and this is one of the biggest ship. India is going to give one IAC, that is Indian Aircraft Carrier, that is being built by India itself. First time it is happening for Navy. So this is IAC on. This is not IAC. This is aircraft carrier, and basically we can put the aircrafts on top of it. There are 3 lanes on it. This is 1 lane, this is 2nd lane, and this is 3rd lane. This one is used for there's some arresting key arrangement of the on the deck of this aircraft carrier. Whenever any aircraft is landing on it, that arresting arrangement will arrest it. It will catch it, and it won't be able to go ahead into the water. It is quite a big ship, and its only purpose is to carry the aircrafts. And these yellow things which you can see, it is the crane. What will happen is whenever the aircraft is landing on it, the aircraft will go on top of it, and this crane, this lift will go down, and we can store the aircrafts inside the ship. Inside the ship also we can store the aircrafts. So this was a basic overview of the shipbuilding which I can give you. I hope it was a informative session for you. That's all from my side. If you have some
Thank you,
questions
sir.
and all,
Uh, Thank you, sir. That was a very informative and exciting session. Now we go towards the question section. So if you guys have any question, please post it in the chat section of the YouTube stream. Uh, so we have a question here. It says, "Can you explain what a frigate is?"
frigate. Question is, what is frigate?
Yeah, can you explain what a frigate is? That's a question.
Yeah, as I told you that there are various kind of naval vessels which I have got. So frigate is quite like a destroyer, but frigate has got more ammunitions in it, and it has got more speed. It will go with more speed. And when I start talking of the speed, the speed of the aircraft carrier will be very less because it is a very big ship. But for a frigate, it can be up to 35 knots. When we calculate the speed of the ship, it is calculated only in knots. If you want to convert it into meter per second, you need to multiply it by 0.5144. You can get it in meter per second. But that is the frigate moves with a great speed. That is the basic difference for a frigate. But yes, it has got a slender hull. Its hull is very long in nature. It carries some of the destroying elements also, but you cannot call it as a destroyer. This is the biggest difference between a destroyer and a frigate. I hope I answered your question.
Yeah. Then we have another question. The question is, do we actually have a system of recycling ships?
And do you actually have?
A system of recycling ships.
Yeah, recycling. See, it is a biggest problem in shipping industry. There is no system, but there is management for recycling of ship. This is a vast subject. First of all, the recycling of ship. I'll explain it by, okay. If I talk about a GRP ship, that cannot be recycled because that hull cannot be used again. But when you talk about a steel vessel or a aluminium vessel, we can recycle it because recycling of that vessel is possible because that metal can be used again. There's one more concern with the recycling. Recycling does not means that you are taking some shape and you are using it again. That does not mean the recycling. Recycling means if you have some waste, in case of a ferry which have got batteries, those batteries cannot be used again. So you need to dispose it at somewhere, or you need to dispose in a way that it does not cause any harm to the environment. In that manner, it has to be disposed. So this is also one of the element of the recycling of a ship.
Then next question, I had a personal question.
Okay.
The Indian aircraft carriers have an elevated runway, while most of the United States aircraft carriers have a propulsion system that propels the plane out of the uh, jet of the ship. So why are we not? What's the difference between both of these aircraft takeoff methods from the aircraft carriers?
Okay. See, I'll tell you the example of our aircraft carrier. We are using the sack lift for it, for taking out our aircrafts. The propulsion system which you are telling to take it out, first of all, it needs to be maintained, and we don't have those kind of maintenance facilities here. So what we do is we put a crane, not crane, we put a lift, that is sack lift on the aircraft carrier. So our aircraft is landing, then we put our aircraft on that particular lift, then that lift will take it down. Then there is a turntable inside it, the hangar, we call it hangar, the place where we are storing our aircraft, we call it hangar. In that hangar there is a turntable because that is a very secluded place. What you will do is you will take your aircraft from that particular sack lift onto the turntable. The turntable will move it in a particular direction where you want to take it. There will be some channels, and using that and there is a lift also. Inside that hangar there is a lift. That lift will put the hooks inside that particular aircraft, and will uh, put at the required place or the allotted place of that particular aircraft. So that is why we are not using it. It is also a good mechanism. There is no demerit of it. There is no issue with it.
And there are a lot of different nuclear powered ships and diesel powered ships. So what is the advantage of a nuclear powered ship? over a diesel powered ship, and it's not becoming a convention and a common practice. Only the
Nuclear power
United
ship.
US Navy has it.
Yeah, nuclear power ship are very powerful, but we don't have nuclear power ships. But yes, we have nuclear powered submarines. The nuclear power is being used in submarines, not in ships in India, because nuclear power is a bit of what you can call it. It is bit of prone to accidents. That is why we don't use it. The nuclear power is only used in submarines, and yes, for all submarines we are using nuclear power. There is no doubt in that. But when we have got a good option which is better than the nuclear power, then why should we implement the nuclear power inside our ships? Why should we increase our level of risk by putting nuclear power inside our ship? If some is happening, we lose our entire ship. But in submarine, we don't have any option because we need high power. High power is required, and we cannot give the exhaust. This is one of the factor. In ships, you can leave the exhaust into the air. That is possible. But in the submarine, where will you give the exhaust? Inside water? Not possible. So that is why nuclear is being used in submarines, not in ships. But yes, it can be used, but not required. Not required at all. We can get the same amount of power using the diesel ships and all. Not required.
Then there's another question. Omkar is asking. The question is: do nuclear powered submarines have thicker walls to prevent leakage in case it might occur?
Sorry, I did not get it. Leakage means what?
No, if accident happens, if the nuclear material leaks out, so does the
Yeah,
submarine have thicker walls than compared to a diesel powered submarine?
yeah. Submarine has got double structure. Ship does not have the double structure. Ship has the submarine has got the double structure. The part which you see of a submarine is just a skin. It's just a skin of the submarine. Inside that, it is cylindrical in shape, and we have got stiffeners at particular area. There are lots of stiffeners, stiffening materials. As you can see in your home, no, in your home there are lots of beams and all on the walls to make it more strengthening. So same concept is being followed in the ships, in the submarines also, and in submarine there are two layers, and these two layers are also there in tankers. In some ships also it is there. There is some ship which is carrying the oil, so we need to give the double protection because if there is some leakage of the petrol or diesel inside the water, it will cause harm to the marine life. So double wall. If there is leakage one wall, second wall is there to defend. So it is there.
Yeah, okay. So by this we come to an end to this informative session. Thank you so much, guys, for taking time out of your busy schedule and giving an insight into what happens behind the scenes of a naval warship construction and model making. I also thank the audience for being an active part of this exhibition. Finally, thank you all. Good night. This is Harry signing off. Good night.
Okay. Thanks. Good day. Good day to all.
Thank you, Gaurav.
Thank you, sir.